So let's say I've never seen one of these before, which you guys probably haven't. How would I figure out what the graph should look like? Well, we kind of did this last week, but just make up a bunch of x values and then plug them in, see what comes out, and then those are the points you'll graph. So what might be some good x values to use here?
-1.
-2, -1, 0, 1, 2. Just why did I choose these? Just because they're close to the middle of the graph. So if I plugged in -2 for x, by the way, the y value is also like the f of x value. If I plug in -2 for x, what is this f of x going to equal? 2. Because the absolute value makes everything positive, right? So -2, absolute value of -2 is 2. If I wrote it out, f of -2 equals absolute value of -2, whoops, which is 2. So anyway, when you plug in -2, you get 2. If I plug in -1, absolute value, 1. If I plug in 0, 0. Well, if you plug in 1, absolute value of 1 is still 1. If I plug in 2, still 2. All right, so what is that going to look like? Well, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. What's the pattern? It's a V. It's a very perfect diagonals here. And it does go forever like that. Everything, all the negative x values that you plug in spit out a positive y value. So like when your x is -2, you get +2, -3, 3, and so on. So anyway, kind of bounces like that. It's a V shape. Well, what would happen to the graph if I like put a +1 there or a -2 or something? What do you think will happen to the graph if I put a +1 on the function? What would happen to the y values?
What would be odd?
They would all be 1 bigger. So instead of these, it would be 3, 2, 1, 2, 3. What would the graph look like? So what happened to the graph? How did it change? It went up 1. Okay, so +1 right there, just like you might guess, makes the graph go up 1. Well, guess what would happen if I put a -2 out here? It would go down 2. Okay, now this next trick is where we start getting it wrong. What do you think would happen if I put the -2 inside the absolute value? Well, I said we get it wrong because usually you can't guess what's going to happen. I could let you guess. Now that I've said that, nobody's probably going to want to guess. Anybody want to guess? Well, you subtract 2, but what's that going to do to the graph is the question.
It's like -2 would...
Okay, so here, let's find out. -2 minus 2 is -4. Absolute value of -4 is 4. -1 minus 2 is -3. Notice I'm subtracting first and then I'm doing the absolute value. That comes last. -1 minus 2 is -3. Absolute value of -3. 0 minus 2 is -2. Absolute value. 1 minus 2 is -1. Absolute value. 2 minus 2 is 0. Absolute value of 0 is still 0. Okay, well, let's see what this looks like. Go back up to the graph. So it was -2, 4. Maybe I'll zoom out a little bit. Oh, screwed up. There we go. Okay, -2, 4. 1, 2, 3. It's doing this. That's all we got. What if I plug in 1 more? 3 minus 2 is 1. Absolute value of 1 is 1. You get a point at 3, 1. Okay, it's bouncing over here. So what happened?
It went to One, two spaces forward.
Move 2 units to the right. Okay, you might not have guessed that would do that, right? So, what is the x value effect? What's the x value tell us to do?
Go to the side.
Go right or left. Okay, so when you put a -2 on the x value, it actually affects the left-right movement. But it does the opposite of what you might guess. So if you put a -2 on the x, it actually moves the whole thing right 2.
Because
So,
it's an absolute value.
if it's directly on the x, what?
Because it's an absolute value.
Because, well, these rules actually don't just apply to absolute value. Like later on we'll be graphing quadratic equations like x squared. This would make the graph go up to, this applies to kind of all graphs. This would make it go left to, anyway, this applies to a lot of stuff. But when you put it directly on the x, it affects the x motion, right and left, but it does the opposite of what it looks like. So if it says -2, it actually moves it right 2. So guess what if it had said x plus 2 in there? It would move it left 2. Okay, so notice though when it moved it right 2, the graph did, the numbers that I chose did not work very well. So when it moves it right 2, you might want your center x value that you used to be 2. So maybe I would plug in 0, 1, 2, 3, 4 for my x values. That way I could see the v. Because before I plugged in that last point, it just looked like a line, right? So I had to go 1 over because the center of the graph is at 2 on this one. By the way, I forgot to label this. This point, this bottom point on the v's, and this applies to other stuff too, but this bottom point is called the vertex. You guys heard that word before? It's what they call a corner point in an angular shape. But they call it on these absolute value vertex. So on a normal vertex, it's 0, 0. Okay, if you go up 1, it's at 0, 1, or if you go right 2, it's at 2, 0. But normally the vertex starts at 0, 0. All right, let's look at number 1. Okay, make a table of at least 7 ordered pairs. I'm going to shrink that down to, well, I'm going to shrink that down to 5 ordered pairs. Well, let's do 5. And graph each function. So 1 through 6 is graphing, the rest of it is not. Okay, number 1, based on what we talked about, it's okay if you don't have this memorized, but what does the -4, what do you guys think that'll do to the graph? What do you think that'll do to the graph? No.
It would just subtract.
Okay, this was like our first thing here. Remember what that did to it? Well, originally it was a plus. That, well, it was a +1 originally, I guess. That moved it up 1. When it's not on the x, it just moves the graph up or down. So this -4, it's not directly on the x, it should move the whole graph down 4. But we're supposed to make a table. So if it's moved down 4, the center of the graph is still in the middle at 0. So I'm just going to use those 5 x values centered around 0. All right. Since I know the graph is going to move down 4, I might put my x-axis a little bit higher, because you know everything's going to happen like down here. Okay, anyway, if I plug in -2, absolute value of -2 is 2 minus 4, -2, and then -1, absolute value is 1 minus 4.
So it has to be 7 ordered.
I know, I said 5.
Okay.
0 minus 4. Okay, 1, absolute value is still 1, minus 4. 2 minus 4. Alright, you can kind of see a pattern here. It's going down, down, and then it bounces, and it goes up, up. It's a V shape. So negative 2, negative 2, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, negative 2. And go ahead and draw the lines through the points, not just to the points, because these graphs do go forever. So it's a V shape and it's down 4. I'm going to go ahead and I guess I don't need this anymore. What color do we want to do? Let's do this one. Run out of ink. All right. What will this plus 2 do to the graph?
Go up 2.
That'll be an up 2. What will this minus 2 do to the graph?
Go
Down 2. What will this plus 2 do to the
2.
graph?
Go right 2.
Okay, it does the opposite when it's in there. So it's going to move the graph left 2. And this will move the graph right 2. It's kind of like, I don't know if this will help anybody, it kind of helps me. It's like it makes the graph happen 2 later, so it's like 2 to the right. Minus 2 in the x. Alright. So, these are the patterns. These two are kind of a little bit obvious, I feel like. Up 2, down 2. These are, when it's on the x, it affects the x motion, but it does the opposite of what you might guess. So, left 2, right 2. What is the pattern? I'll probably be able to squeeze that in there. Okay, number 3. Okay, it says y equals absolute x plus 3. What's that going to do to our graph?
Go down 3.
No.
Go left 3.
Left 3.
Left 3. Okay, if it's moving left 3, what x value would be the middle of the graph?
Negative 3.
Negative 3. So we might want to choose, to get a better picture of the graph, we might want to choose x values around negative 3. Because I'm expecting the graph to move left 3. That means everything's happening over here. So I'm going to use negative 3. What two numbers are less than negative 3?
Negative 2.
No, negative 5 and negative 4 are less than negative 3. And what are the two numbers bigger than negative 3?
There are 2, negative 1.
So if I plug in negative 5 plus 3 is negative 2, but then you do the absolute value after, so that's positive 2. Negative 4 plus 3 is negative 1, absolute value. Negative 3 plus 3 is 0, absolute value. Negative 2 plus 3 is 1, absolute value doesn't change it. Negative 1 plus 3 is 2. So 1, 2, 3, 4, 5. What if I had just chosen x values like negative? What if I had just chosen the standard x values of -2, -1, 0, 1, 2? What if I just used those 5?
A
What
little
would,
bit of line.
okay, I would have just seen x value, x is -2 is right here. I would have just seen this. It would just look like a line. So I wouldn't have seen the b unless I kept going to the left. All right. One more. Uno mas. It says -2 minus 3. Okay. What's this -2 going to do to the graph?
Go
Right two.
Right 2. What's the -3 going to do to the graph?
down 3.
Down 3. Moves the graph down 3. Alright. So I should expect the graph to be right 2 and down 3. So maybe somewhere in the 4th quadrant. You guys remember the quadrants? A good time to remind you. 1, 2, 3, 4. And since I'm expecting the graph to move right 2 and down 3, most of what's going to happen is over here. Okay. So what x value would be the middle of my graph? If it's moving right 2, the middle x value would be at 2, positive 2. So what are the numbers around 2? 0, 1, and 3, 4. So if I plug in 0, 0 minus 2 is -2. Absolute value is 2. Minus 3 is -1. If I plug in 1 minus 2 is -1. Absolute value 1 minus 3. If I plug in 2, 2 minus 2 is 0. Minus 3. 3 minus 2 is 1. 1 minus 3. And 4 minus 2 is 2, minus 3. So it's getting at the low point at 2 and then starts bouncing up again. So 0, -1 means right 0, down 1. This means right 1, down 2. Right 2, down 3. Right 3, down 2. Right 4, down 3. Oh boy. Okay. The reason we draw solid lines is because all the points on these lines, even the ones that I didn't make circles for, are solutions. For example, right here, it should have hit the line at 1, 2, 3, 4, 5. It should hit the line at 5, 0. Now I didn't find 5, 0. It's not in my table, but it is one of the solutions. Here's a random point. That's like at 3.5, -1.5. That should be a solution for this equation. Like if I plug in 3.5 for x, I should expect to get -1.5 for the y value. or the function value. The y-axis is also the x axis. Anyway, that's why we draw lines, because all these infinite points on here represent the infinite solutions that work in this equation. Okay, done with graphing. Now the rest of this is going to go pretty fast. We don't really need graph paper for it. So, are you ready? Number 7, and I'm going to, it's been a long time, but I'm going to call on people. Anybody want to volunteer to start? Okay, James. Number 7, so it says describe the translation. That just means describe how the graph's going to move from the original y equals absolute value of x. What's the plus 4 going to do to the graph?
It's gonna move it up 4.
So all we have to do on 7 is put a 4. See how this is going to go quickly? Which way do we want to go? Alright, we'll go that way. Okay, Devin. Number 9, what's the minus 10 going to do?
It's gonna go left.
Wait, did I say Devin? Devin. What's the minus 10 going to do?
It's gonna go left 3.
Look at number 9 though. What's
Oh my god. It's gonna go to the right 10.
right 10? Okay, because it looks like this one. It's at minus 10 instead of minus 2. Number 11, Lauren, what's that plus 1/2 going to do? Number 11.
Oh, sorry, I was looking at the
Up 1/2. Okay, 13. Okay, this is kind of the opposite. We're supposed to write a function rule for this. Like they're telling us on 13 that the function is supposed to go down 2.5 from the normal. So, Mallory, how do we make the graph go down 2.5?
X minus 2.5.
Okay, well, you gotta be a little more specific. Should the absolute value be around the x or the whole thing?
The X.
Okay, yeah. Absolute value of x and then minus 2.5. That's how you make it go down 2.5. All right. Luke, I just had deja vu. How do we make the graph go 4 left?
X plus 4?
Yes. Well, no, sorry. Wait, was it left? Yes. No, you're right, my bad. X plus 4, all of in the absolute values. Yes. Number 17. All right, it's kind of the same thing, just a little bit amped up. Hannah, what's the minus 3 and the minus 4? What's that? How's that going to move the graph? On number 17.
right 3 and then down 4.
Right 3, down 4, yes. $19, Manny, how's that graph going to move?
It's gonna move it left 7. Up 1.
Maybe I should, on the video, show this. This is what we're looking at to help us out. Yeah, there we go. Screenshot. All right. 21. A little bit late for that. Okay, this is a little bit different. It says state the coordinates of the vertex of each function. The vertex is that bottom point of the V. Okay, so on a normal, like y equals absolute value of x, whoops, the vertex is at 0, 0. But if the graph moves up 1, if the graph is up here, if the graph moves up 1, then that would be at 0, 1, the vertex. Or if the graph is right 2, it would be, the vertex is at 2, 0. So the left or right is going to affect the x-coordinate of the vertex, and if it moves up or down, that affects the y-coordinate of the vertex. Okay, so Avery, on 21, first describe to me how that graph would move, just like we did on 19. How would that graph move on 21?
Go left 5 and up 3.
Okay, so it's like the whole graph moved left 5 and up 3. So Avery, what point is left 5 and up 3? What point would be left 5? How do you get to left 5? Negative 5, and it'd be at negative 5. If the whole graph moves left 5 up 3, then the vertex moves left 5 up 3. So therefore the vertex is at negative 5, 3. Okay, 23. Uh-oh. AJ, how's that graph gonna move? Minus A, what's that gonna do to the graph?
It's going to push it to the right.
Right A, and then what's the plus B gonna do to the graph?
Up.
Up B. So,
Down A, up, right A, up.
right A, up B. What would the coordinates of the point be if we went right A, up B? What would the coordinates of those points be?
Negative A,
Now, if you're going right A, is that more like a negative or a positive?
or at least like,
That'd be positive A.
so AB.
Yeah. And up B is a positive B. Okay, 25, almost done. Let's see, Hank, we're supposed to write the function again like we did on 13 and those problems. How do I write a function that moves left 2 and up 6?
X plus 2 plus 6. Well, x plus 2 and absolute value.
Yeah, that's the left 2, and that's the up 6. Okay, Wyatt's 27. How do we go 5.9 up and 6.23 to the right?
It would be X, an absolute value, plus 5.9.
No. Okay, they kind of switched it around on us. How do I go 5.9 up? On the last one, this was 6 up right here. So that plus whatever should be outside the absolute value. 5.9.
X plus 6.23.
How do we go to the right? Minus. So, didn't leave myself enough room. Alright, there we go. Give that a shot. I'll come around and look at your number 2, or if you have any questions you can ask.